Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 20th. I'm Mark Sponsor, and I'll be your host for tonight's presentation. We'll be discussing significant wave heights for the North Pacific Ocean, jet stream level winds, surface level pressure, and all the things that go into producing surf in the North Pacific, and then a look at precipitation, wind swell, and hopefully some snow in the future. Let's get into the details now. Looking at significant wave heights for the North Pacific Ocean, we see a small gale producing 18-foot seas aimed at British Columbia, not really doing a whole lot. Another area fetch starting to develop off of North Japan, again with 18-foot seas, and a tropical system in the far West Pacific, not doing anything of interest yet, but hopefully providing something for the future. As usual, we'll start off looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. Right now, we have a reasonably decent jet stream flow. Better than it was a week ago and better it was a week before that. Semi-consolidated flow pushing off of Japan here with winds in the 140, 150 knot range. A little bit of a split here, but they all join together, forming a trough. That is a dip in the jet stream. That's what we want to see, because that dip, basically traveling like that, helps create a counterclockwise flow in the upper atmosphere and down at the ocean surface. And a counterclockwise flow is the hallmark of low pressure. And of course, low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. All right, so we do have a bit of a trough here over the North Dateline region right there. Maybe capable of generating something, but nothing real obvious is happening quite yet. And then we have the consolidated flow ridging to the north through the Gulf of Alaska. That supports the exact opposite, a clockwise flow aloft and at the surface, and that's the hallmark of high pressure. So that typically means wind for California, wind for Hawaii when it's in this position, and maybe some low pressure developing here. All right, let's put this into motion. As we move into Monday, same sort of pattern exists. The trough morphing a little bit, but the good news is the jet becomes more consolidated, pushing off Japan, and that's what you want, consolidated wind, because that helps, generate more winds, and that feeds trough development. So we have a bit of a trough forecast Wednesday pushing through the Gulf. Nothing huge, but something. Ridge holds over the U.S. West Coast. The West Coast. And then we get into Thursday, kind of a mixed pattern, but look at this, a trough starting to develop, pushing off Japan, building. Look at it. There's actually a decent trough with, 170 knot wind starting to build down its apex. That's good. That should support low pressure development as we get into Friday. And then the trough starts pinching off Saturday over the North Dateline region. Notice this big ridge holding here over the Gulf of Alaska. That will shut down any storm development there. Then the trough pinches off as we get into Sunday. We're almost a week out, and almost the beginnings of another trough starting to show again over the North Dateline region. So for the immediate time being, it seems like the North Dateline region is going to be where all the action is. Let's go take a look down at the surface. So here we are, surface level pressure, surface level winds, and right now, as expected, high pressure off the U.S. West Coast, generating wind there, also generating fetch, pushing into Hawaii, wind swell-wise, that is. A little bit of a low, trying to work its way through the Gulf of Alaska today, 35-knot winds, not really doing a whole lot. Another low, trying to organize off Japan. This actually bears some watching for Hawaii, nothing huge, so let's just put it into motion, we'll see. Here we go, 30, 35 knot winds as we get into Monday. Racing east, starting to build with a broader fetch of 35 knot winds. That should generate some swell, but also starting to race off to the northeast. Probably not doing a whole lot after that unless you're up in Alaska, and then for sure, swell there and probably stormy conditions. Another low starts to organize off of Japan on Wednesday. It sort of fumbles around. Also notice, this is new. As we get into Wednesday, Thursday up in the Gulf, 55 knot winds. This wasn't here even on the last run of the model. In fact, let's go back and examine this. So this guy was supposed just to push up into Alaska on Wednesday. Now the models have it stalled over the far eastern Aleutians. Maybe some swell, north-angled swell to result, mainly for Pacific Northwest and down into California. Anyway, our new system starts developing on Thursday and building pretty strongly. This is what was a tropical system, and we'll We'll get into that in a minute. Supposed to go extratropical, tapping the jet stream on Thursday night, building good area 45-knot winds, pushing over the North Dateline region, 50-knot winds, maybe into Friday night. And then it starts fading, moving into the Bering Sea, and yet another system starts to develop off the Kuril Islands on Saturday night into Sunday. This one also looking better than the last run of the models. There's probably just a little bit of hype from the model. It'll mellow out in the next run or two. But still, as we get into Sunday, that's a week from now, if you believe the model's that far off. I don't, but if you do, 45-knot west winds, and yet possibly more swell generation potential. So, for the moment being, the models are looking pretty active. So let's go take a look at the effect of those winds on the ocean surface. Right now, yeah, a little bit of fetch or a little bit of seas trying to develop in the Gulf, but nothing particularly interesting. But you see, remember that low developing off of North Japan tonight into Monday? Was that 18, 20-foot seas? Then it sort of fragments. It's racing east so quickly, the winds don't get much time to start blowing on the ocean surface, generating any seas of real interest. Anyway, we get into Tuesday, yeah, what was that? More like wind swell, 17, 18 foot seas at best, and then the low starts racing off to the north. Notice there was two tropical systems, one of them here, another behind, so let's see how this goes. And then here's the new thing on Wednesday. What is that? 38-foot seas, 39-foot seas, pushing 46-foot seas, all aim pretty well to the northeast, but you would get some sideband swell if this materializes, radiating down into California, probably from a pretty north angle, maybe even some energy for Hawaii, but that's probably not real likely. New system, tropical system, turning extratropical on Thursday, building as it approaches the North Dateline region, 30-foot seas, pushing to, what is that, probably about 38-foot seas. The models had it a little bit higher the last run. It fades out, and then again another area of 35-foot seas builds as it regenerates on Friday night, and then fading out again, setting up good north-angled swell for the Hawaiian Islands and energy for the U.S. West Coast. And now, yet perhaps another system behind that as we get into Sunday with 40-foot seas aimed off to the east. So this is actually looking pretty decent. It's almost like fall is starting to develop. And the interesting thing is that's happening even with a strong inactive phase of the MJO in control. We'll get into that in a minute. Let's take a quick look at the track for Typhoon Bualoi. I think I got that pronunciation right. Currently, east of Guam, about 300 miles, 75-knot winds. Forecast to build 100-knot winds as we get into tomorrow. That it would be on Monday with 115-mile-an-hour winds. And then building, peaking out the day after that, Tuesday into Wednesday with 115-knot winds. That's about 130, 135 miles per hour, and then recurving. And this is really interesting. Recurving with a strong inactive phase of the MJO in control. That is not usually what happens. Normally, you get this big high pressure and it just drives them right into this area. But no, that's not the case. Recurving to the northeast, we'll take it, pushing off Japan as we get into Friday with 90-knot winds, and then forecast to redevelop after that, as we saw in the previous models. So, not a bad setup at all. So let's take a quick look at wind swell and wind swell generation potential for the next week. So, today we have high pressures, pretty strong, solid 1028 millibar high pressure. As we saw with the jet stream, with it ridging to the north, that supports high pressure. And sure enough, we have it as expected in the Gulf of Alaska, generating, so it high pressure circulates clockwise in the North Pacific. That generates north winds, as you can see, about 20 knots off of central California, making maybe some wind swell, but there's actually swell, previous existing swell in the water from a gale previously in the Gulf of Alaska, but that's starting to fade out now. But also a good fetch of east winds off the south end of this high, aimed at Hawaii, likely starting to generate east wind swell, impacting the islands there. Put this into motion as we get into Monday. More of the same, the fetch, 20-knot north winds, now pushing up into North California. Wind swell there, but probably mixed a lot with fading remnants of Gulf swell. And then East winds continue for Hawaii, again, producing wind swell there. As we get into Tuesday, the high lifts to the north a little bit. Notice low pressure out here. This is that one that was targeting some swell for Hawaii and then starts lifting north. Anyway, on Tuesday, wind swell, again, for California, 20-25 knot winds, mainly off of northern California. East wind swell for the Hawaiian Islands, too. 15 knot east winds continue there. We get into Wednesday. You can see a good close look here at our low up in, actually, storm. If you have winds more than 50 knots, that's considered a storm. So a solid storm over the just south of the eastern Aleutians. But right now we're looking at wind swell. More wind swell for California, 20-25 knot winds there, and more east winds for Hawaii. High pressure just in control, locking it down. Thursday, more of the same sort of deal, though the high starts looking to move into the Four Corners region up here. North winds, 20-25 knots off of Cape Mendocino, South Oregon, generating wind swell for California. Winds die down, though, along the California coast. Interesting point, water temperatures, pretty cold for this time of year, October, and it's estimated, just based on what we felt this weekend, probably 53-degree water off of San Francisco. This time of year, normally you'd be expecting 55, 56. A couple degrees makes a big difference. A bit warmer down in Southern California. Anyway, so the wind swell continues Thursday, and then Friday it looks like, again, more high pressure starts moving into the picture. North winds, 20-25 knots over Cape Mendocino, generating wind swell down in California. Nothing for Hawaii, though. Get into Saturday, look at this, almost 40-knot north winds off of Cape Mendocino. Then a couple 100 miles south of there, almost no wind at all over central California. So, more wind swell, the expected result. And then we get into Sunday, still 30-35 knot winds off of Cape Mendocino. This high pressure just locked in, 1036 millibar high, all being fed by that ridging pattern in the jet stream, while all the storm activity for now remains backed over towards the Dateline region and the West Pacific. All right, let's move on. Let's take a look, see if there's any hope for precipitation. Here we go, surface level pressure and precipitation. Now we see high pressure ridging into the U.S. West Coast. Precipitation, yeah, for the Pacific Northwest, but mainly up in the Vancouver area, some snow there as of tonight. And yet another system in that same Washington, Vancouver, British Columbia area sort of thing, with a little bit making it down into Oregon, but nothing for California, high and dry. And as high pressure ridges into there, that will even lock things down more. Everything to the north, up in mainly British Columbia, maybe the northernmost tier states. And look at that, high pressure just locking the entire Canadian and U.S. West Coast down as we get a week out from now. So a little bit early for any snow in Tahoe. We did have some, what was that, a week and a half ago, 2 weeks ago, but that's all fading out now. High and dry for a little bit. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and, of course, El Nino or La Nina? What's it going to be? A little bit of both or neither? We'll find out. So first off, we'll start with the MJO. We like to look or inspect winds in the West Pacific in an area we call the Kelvin Wave generation area, basically the far West Pacific. It's a box starting at 170 west. So here's the date line here. Let's look at this. Date line there, the equator there. This is the East Pacific. This is the West Pacific. That's New Guinea right there. Kelvin Wave generation area from 170 west, 5 degrees north and south of the equator, the whole way over to as far west in the Pacific as you can get, about 135 east. Draw a box right there. We're looking at winds in this area. So we see in the East Pacific, winds, we're just looking at the arrows, pretty strong out of the east. That's typical. Then fading somewhat as we get towards the Central Pacific, but then again out of the east in the West Pacific in the Kelvin Wave generation area, but not as strong. It's not so much the absolute winds, though. It's the anomalies, the differences from normal for this time of year. Are these winds stronger than normal or weaker than normal? Well, so we look at the arrows here, and you see a little bit out of the east. So, yeah, maybe these east winds here are a little bit stronger than normal. That would cause some upwelling in this area. But over the Central Pacific, really no arrows, so it means that's about normal. And in the West Pacific, we see, so the actual winds are out of the east, but they're a little bit weaker than normal according to this, or just barely normal, so basically neutral. If you have west anomalies in the Kelvin Wave generation area for a long period, for a couple of weeks, that's not that long a period of time, that suggests perhaps the active phase of the MJO. And of course, the active phase of the MJO helps feed energy into the jet stream and helps feed the storm track. And then the inactive phase, well, then typically you see east winds in this part in the Kelvin Wave generation area, and that normally stomps on storm development, steals energy from the jet stream, doesn't import moisture into the upper atmosphere, and just not real good for storm development. And as you're going to see in a minute, we think we're in the inactive phase, but we looked at all the models, and it sort of looks like, hey, even regardless of that, we're going to get some storm development. So that's a good sign. So this is 850 millibar zonal wind anomalies. So what's that mean? It's a fancy way of saying, are the winds more out of the east or more out of the west than normal for this time of year? And this is across the entire planet, and it's up at about 4,700 feet. But that's a pretty good proxy for what's going on down at the surface. All right, so where are we? This is the whole planet on one chart. The Pacific Ocean starts at about 135 east, so right there. It goes the whole way over to about 80. Ecuador would be right about here on the equator. So, but the Kelvin Wave generation area, that's what we're most interested in. So from about here to about here, and you just go right up the chart, okay? And this is past history here. So it's September. See all that oranges and reds? That is westerly anomalies, probably indicative of the active phase of the MJO. But notice here's where we are today. We see blues in this area, and they're supposed to build the whole way through this week, reaching to a point south of California on the equator a week from now. This is 7 days. Okay, we're not looking at this right now, just this here. This is a clear sign of the inactive phase of the MJO. So this is a bit of a head scratcher. We have the inactive phase, but yet the models are saying, hey, we got a pretty good run of storm development. But notice we also have a pretty good run of high pressure, and the storms are all trying to build and sort of wrap around the highs, squeeze in wherever they can. And that's because we think the inactive phase of the MJO is supporting high pressure development over the bulk of the North Pacific for now. Also notice, this has been going on since late September. Massive easterly anomalies centered at about 70 east. That's in the Indian Ocean. Of no concern to us. And typically that would be a sign of like some massive La Nina system there, and one would expect westerly anomalies somewhere in the Pacific. But for now, that's not exactly what's happening. Looking at another MJO, this is a statistical model. And what this is looking at, where is it? Right there. Outgoing long wave radiation, ORL. Fancy word for sunlight reflectivity off the ocean surface, which is another fancy way of saying if you have high pressure here, which would be the inactive phase of the MJO, you'd have not a lot of clouds, you get a lot of sunlight reflectivity. And so this suggests the inactive phase of the MJO. There's Australia, there's New Guinea there, Philippines, the equator running right along there. There's South America and Central America. You get the picture, okay? There's our active phase, supposedly, in the Indian Ocean, and the inactive phase in the West Pacific. Pretty strong, in control, supposed to last for about 5 days, and then magically fading out according to this model, with perhaps the active phase of the MJO starting to build in the far West Pacific 2 weeks out from now. Now, the dynamic model, the GEFS model, says basically the same thing for the first 5 days, but then the inactive phase takes a little bit longer to fade out and is not completely gone 2 weeks from now, and the active phase is not moving from the Indian Ocean into the West Pacific. So a little bit of variation of the two models here, but not horribly off. The good news is the inactive phase on both models is supposed to start be fading out pretty good by 2 weeks from now. Taking a quick look at phase diagrams, here's another way of depicting the MJO. So this circle here, two different models, statistical and dynamic. Now assume you're looking down on the North Pole, and this circle is the North Pole. And the MJO moves on the equator from west to east, from the Indian Ocean over the maritime continent, that'd be like Bali, over the West Pacific, over the East Pacific, under the United States, across the Atlantic, across North Africa back to the Indian Ocean. So wherever the active phase is, the inactive phase is basically on the other side of the chart. So we could say active phase right now, is where the heavy dot is, and the further it is away from the circle, the stronger it is. So we'll say a modest, probably, active phase in the far west Indian Ocean. And then we would say the inactive phase is probably over the West Pacific, which seems about right. That per the statistic model. Dynamic model, and the statistic model says, so each one of these dots is a day. So 14, 15 days out, this model predicts the active phase finally moving over the maritime continent, maybe in the far, far western Pacific. But because the dots are inside the circle, very weak indeed. The dynamic model, basically saying the same thing. A little bit of a variation, but basically the same thing. So by and large, the models are in sync. The 40-day upper level model has finally updated. We haven't shown it for 2 or 3 of these different presentations because it hasn't updated, but now, for whatever reason, NOAA caught up with it and they've updated it. So, what is this? Basically, it's a chart that shows you the potential for precipitation, and that can be loosely construed to be the active or the inactive phase of the MJO. Oranges and yellows are dry conditions, okay? And there is Australia, New Guinea there. There is the equator right there, South America. As you see, inactive phase, dry conditions in the West Pacific, moving slowly into Central America through about the 4th of November. Then after that, you can see the active phase moving into the far West Pacific about the 4th of November, and then it too making its way across the Pacific through the end of the model run on November 29th. And at that time, an inactive phase of the MJO starting to build in the West Pacific. So why are we showing all this? Because we know that the active phase of the MJO is the sweet spot for feeding storm development. So if you're looking for when is a good time to go surfing, like a long-range forecast, it's looking like, according to this, as you get into November when the active phase is traversing the Pacific Ocean, that would be the best shot for storm development and therefore swell production. Next, we look at the CFS model, and this is really an MJO El Nino kind of model, 850 millibar wind anomalies, but going out 4 weeks. All right, so this is the whole planet on one chart again. West Pacific, again, at about 135 east, and the Kelvin Wave generation going to about 170 west, so straight up here. The oranges and reds are westerly anomalies. You can see late August, the whole way through September, and actually this dark contour here, that is the active phase of the MJO. So it was in control all the way through till about, maybe mid to late September. And now look at this. Here's today's situation. The dotted contour is the inactive phase of the MJO. And the blues are easterly anomalies. The orange and the reds were westerly anomalies. So we have easterly anomalies in the Kelvin Wave generation area. And that's pretty classic, inactive phase of the MJO. And each one of these tick marks is a week. So that's supposed to go for about a week, let's say a week and a half. As we get into the early part of November, the inactive phase phase out. And look at this. Westerly anomalies start building. Here's the core of the Kelvin Wave generation area between these tick marks right here, filling it. And there, in fact, is the active phase of the MJO setting up. So again, this model also says as we get into, let's say, Halloween, the whole way into November, active phase of the MJO in control, that would be a big red X for a good time to catch waves. And then the 3-month, going out 3 months, do you believe that? We don't, but it's fun to look at. So this is the CFS model, long range, 850 millibar wind anomalies. So again, winds, east-west component of the wind, up about 4,700 feet. Now, again, Kelvin Wave generation area between here and about here going straight up through the chart. And you can see here was that big thing, the westerly anomalies in August and September, active phase of the MJO. It faded. Look at this. The blues that are all strong easterly anomalies in the Indian Ocean working their way the whole way over the Kelvin Wave generation area and the whole way to a point south of California for about the next week, let's say. Let's overlay the MJO. There we go. Dotted contour is the inactive phase of the MJO. The worst of it it looks like is happening right now for the next 5 to 7 days. Then after that, westerly anomalies are supposed to start building in the Kelvin wave generation area in advance of the next active phase of the MJO, which starts November 4th, 5th, something like that, and runs pretty much through the whole month of November. Again, confirming that, November is probably a good time for larger wave production and maybe a little bit more of it than normal. Then again, in a weak inactive phase sets up, but notice no easterly anomalies forecast in the Kelvin wave generation area, and westerly anomalies continue through the middle of January, though there's no strong MJO signal. And then, of course, the low-pass filter. So this is basically the solid contour is in a perfect position right on the date line in the Kelvin wave generation area. And we've been talking about this for weeks now. It died, it faded, it looked like it was going to completely disappear 2 or 3 months ago. And now all of a sudden, we have 2 contours of low-pressure bias over the Kelvin wave generation area, and forecast to go to 3 contour lines as we get into the early part of December. I mean, this would almost look like some sort of a weak El Nino. We don't really think that it is, but it looks like it's at least supportive of storm development and feeding the jet stream energy as we get well into winter. That's a good sign. Also notice this dotted contour here. This is at like 80 east. That's in the middle of the Indian Ocean. So that further looks like some sort of El Nino-ish like pattern, but we know that's not going to happen. But if anything, it just suggests, well, we're not going into La Nina, according to this model. If nothing else, we'll at least be neutral or maybe a little bit biased towards a favorable storm pattern for the next several months. And that is good news. All right, let's go take a look down in the ocean. Enough of the MJO thing. I mean, we got a pretty good handle on what's going on. So now we're going to go sort of more long-term. What's going on with La Nina, El Nino? Where are we going? We've got to look at the ocean first, all right? So here's the far west Pacific. Here's the East Pacific. This is sea surface temperatures, not surface temperatures, but subsurface temperatures. So these are the anchor lines on the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. And you take each one of these little X's as a sensor on the anchor line. They report back temperature data at depth, at down 250 meters in the ocean, 300 meters. It's really the bottom. The top, 150 meters that we're most concerned with. And you see a pattern here. We use a model to take the data, fill in the gaps. You see warm water, 30 degrees Celsius water, about steady where it was last week, reaching east to about 175 east. The 29-degree isotherm, holding about the same at 167 west. The 28-degree isotherm, also at about 152 west. This is where it's been for a couple of weeks now. But this, the 24-degree isotherm has made a jog to the east to 105 west. It was back at 120 a couple weeks ago, slowly moving to the east. The point being, this suggests that warm water is pushing to the east, like a Kelvin wave is in flight. In fact, here we go. Anomalies, differences from normal for this time of year. So if you were watching this, a month ago, right in this area, there's a big old pocket of really cold water, like 4 degrees Celsius below normal. Would there be 6 or 7 degrees Fahrenheit below normal, sitting right here and pretty much filling this entire area? In fact, there was a wall at 150 west. So where's 150? That is right about here. Cold water on this side, warm water on this side, stationary Kelvin wave. And what's happened over the past month? Warm water has pushed steadily east. Okay, so what's that mean? Well, that is what a Kelvin wave is. So we monitor the Kelvin wave generation area for signs of the active phase of the MJO, and what we're looking for is westerly anomalies, because they take that pool of warm water that's right there, and they'll start pushing it east. It'll fall to depth. It doesn't travel on the surface. It travels below the surface, right under the equator, then starts pushing east over a 3-month period, then eventually erupts off of Ecuador, and then forms a warm slick on the ocean surface off of Ecuador that then gets caught by the trades, and that warm water starts pushing back to the west. If you get enough Kelvin waves and they're strong enough, that's sometimes how El Nino starts. Now, we don't see that happening. This looks like a bare, minimal, very weak Kelvin wave. But you know what? Any warm water transport to the east is far better than cold water setting up, because if you have cold water in control of the East Pacific, then you're in La Nina, and we don't want to be there. Here's another model's version of subsurface temperature anomalies, and it's showing basically the same thing. This runs a little bit behind the other one. The other one's like updated daily. This is like once a week sort of thing. But still, you see warm water, the reds, let's see, 1, 2, 3, 4 contours, 1, 2, 3, 4. So 2 to 3 degrees Celsius anomalies, and they are definitely moving to the east. This area of cool water here was a bit larger last week. Now it's down to, somewhere around 105, 110 west, and definitely getting squeezed to the surface while warm water builds and pushes to the east. So again, pretty much telling us the same story. Upper ocean heat anomalies. All right, so what's this? This is the West Pacific here. This is the East Pacific here. The reds are showing warm water traveling, or basically Kelvin waves traveling from west to east. The good news is we have Kelvin waves to show you. So we were in sort of a weak El Nino type thing, was it last winter? And here is back November 2018, one Kelvin wave moving from west to east. Another one, I think this was Kelvin wave number 4, moving from west to east. Then a couple of other spurts in June and we'll say July-ish time frame. But we're not even going to call these Kelvin waves. They were just here. They didn't go anywhere. They didn't make it east. They just sort of stalled. But then we'll call this Kelvin wave number 5. Very weak, but it's what's in flight right now. And you see steady eastward progression of warm water, currently today making it to about 110 west. So that's south of Mexico somewhere, mid-central Mexico sort of thing, and looking to possibly make it the whole way to Ecuador. So this is kind of a good sign. I mean, it's a nice way to kick off your fall. The problem is there's been a lot of cold water, and we think that cold water has and it's in the East Pacific, certainly has had an effect on the jet stream over the Gulf of Alaska, certainly causing the jet to ridge to the north, where most of the warm water is over the Central and West Pacific. So it's no big surprise that all the storm production that's been forecast is now setting up like over the date line into the Western Gulf, but not making it currently into the Gulf. Also, having the inactive phase of the MJO in the Pacific isn't helping things at all. But I think as we get our way further into November, with this Kelvin wave in flight, with warm water building in the East Pacific, and the active phase in flow, I think our odds for storm production in November are looking much better. Let's take a quick look at sea level anomalies. So what's this? It's basically, if you look at the ocean, so there's Central America, Peru, Australia, New Zealand, there's the equator, there's the date line there. So, and we're only interested in the area 5 degrees north and south of the equator, because that's where Kelvin waves travel from west to east. And what do we see here? The oranges are positive anomalies. So 5 centimeter anomalies in the area of the date line. So what's that mean? Well, this is from the Jason satellites. They strip out all the sea heights, strip out the wind waves, strip out the tides. What we have is a 5 centimeter bump on the ocean surface. And what that means is there's warm water at depth. Warm water expands, and with the expansion of that warm water, it pushes the ocean surface up just a little bit, and the satellite is so sensitive it can detect that. So what that suggests is that there's warm water under the date line, and actually a finger of it moving off to the east. Here's the remnants of that cold flow that we were talking about from a month or two ago. It is significantly retracted, still has a little finger here south of the equator, but it's 5 degrees north and south. So yeah, barely in there, but it looks like it's getting shunted back while warm water, this Kelvin wave, starts pushing east. So again, more confirmation of what we're seeing in the other charts. All right, so let's go take a look at sea surface temperatures, all right? What's happening? Now here, again, a little bit of mixed signals. At a couple of days ago, we got some indications of warming really building in this area. Now, all of a sudden today, yeah, there's cooling. I mean, this is nothing remarkable in this area. This is pretty normal, actually. See a little bit of cooling off of Peru. But the warming that was building out here is fading significantly, and the cooling is setting up even up into Mexico now. And it just sort of seems, and there was warming starting to build in this area. That's retracted now. So there's this dynamic going on where it's warm, it's cool, it's sort of, there's a battle going on in the East Pacific. Are we going to get warm? Are we going to get cool? I mean, the odds are probably in favor of cooling. In fact, a couple of weeks ago, we were saying for sure we're moving towards La Nina. Then things started getting warmer, going, oh my goodness, and we see this Kelvin wave starting to develop. It's like, hey, maybe we're not moving towards La Nina. But now it seems like the cool dynamic is starting to get the upper hand again. But the official El Nino monitoring region is from 120 west, that's south of California, 5 degrees north and south of the equator, on out to 170 west, so out like in here. You see, yeah, things are looking pretty warm there. This area is noisy. This is what they call like the Nino 1.2 region, and this is Nino 3.4 out here. So in the official El Nino monitoring region, we're warmer than normal, but over here in sort of the birthing ground where Kelvin waves erupt, it's kind of cooler than normal. But, you know, this could be due to that last little pocket of cool water getting squeezed to the surface before the Kelvin wave starts moving into this area. So, we just, you know, it's always a game. You never know exactly what's going on, but you can make some guesses, and we think that's what's happening. The last of the cool water erupting from what we thought was like a cold Kelvin wave, a La Nina wave, if you will, but maybe that's getting squeezed out, and maybe we're going to move into a warmer regime 3 or 4 weeks out from now. I mean, it would actually be pretty cool to see it warming here at the same time as the active phase of the MJO sets up in the West Pacific. That would only do anything to, that would only help the jet stream even more. Here's the sea surface temperature trend for the past 7 days. So somewhere about midweek, it was getting pretty warm over here. We're like, oh, really surprised. But now today, boom, 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 pockets of cooling starting to show up. And there was a pretty broad pocket of warming off here. Now it's starting to moderate a little bit. So there's this kind of oscillation thing going on between the cool water and the warm water. Not necessarily cool, not necessarily warm, just sort of bouncing in between, somewhere around neutral more than likely. And then finally, sea surface temperature anomalies, just the real data as of right now. And you see, yeah, it's warm all over the North Pacific. Kelvin wave generation over here, it's warm. But in the Nino regions, see a pretty broad area of generalized cooling off of Chile and Peru, South America. And on the equator, yeah, it's warming, but it's not cooking warm. I mean, it's just kind of all said and done. It's neither El Nino nor La Nina, just kind of neutral. At least that's what it looks like from this chart. Let's go look at some other data. Here's the sea surface temperature trend in the Nino 1.2 region, that area off of Peru that looks cool. Well, it is. So today's value, minus 0.395, third of a degree, something like that, below normal. But you can see it was down to 2 degrees below normal in early October and almost that far in early September. So generally, a cool regime has been in control of the Nino 1.2 region since all summer, basically. The Nino 3.4 region, though, the official El Nino monitoring region, is trying to warm a little bit, and you can see that on the other charts. But it was quite cold back in August and September, down half a degree below normal, starting to recover some but not really, 0.227, 0.2 of a degree above normal. So basically neutral temperatures, and it's only been that way for 3 weeks, something like that. Before that, for all of August and all of September, it was below normal. So what's going on in the atmosphere above the ocean, and specifically the Southern Oscillation Index? This is sort of an atmospheric index used for measuring. You can tease out the MJO from it, but you can also it's mainly an El Nino La Nina indicator. So it's the difference in pressure between Tahiti and Darwin, Australia. When the pressure is lower, the index goes over Tahiti, which is a sign of El Nino. The index goes negative. When you're in the inactive phase or you're in La Nina, the index goes positive. All right, so the daily contribution, very noisy. Today it is positive 11.21. That doesn't mean a whole lot. You can just sort of look at the numbers here back the past month, and it's been toggling all over the place. But today, positive. The 30-day average sort of squeezes some of the noise out of the numbers and gives you a better indication of whether you're in the active phase or the inactive phase of the MJO. And looking here, going back in time, you see we're at minus 15. So that was probably the active phase of the MJO in September and early October. And now we're almost dead neutral at minus 3.96. So probably trending towards the inactive phase of the MJO. And we know from looking at all the other data, we're definitely in the inactive phase of the MJO. This is sort of a lagging indicator. 90-day average, you can use this for monitoring El Nino, La Nina. It really takes the noise out. We're at minus 6.16. If you were in El Nino, this would need to be down about minus 15. What have we been for the past month? Oh, we're at minus 0.8, 0.63. So that isn't even El Nino. So we're in a neutral pattern biased a little bit towards El Nino and getting weaker by the day, but nothing dramatically so. So basically, ENSO neutral, and I think that's the official NOAA indication is ENSO neutral. So finally, what's the official forecast for the Nino 3.4 region from the CFS version 2 model? This is the official El Nino monitoring region. So this is as of October 16th. There we go. You can see the date there. So it's a little bit dated, but not bad. The general outlook, so we're in late October. This is the model. It takes a little while to catch up, but it's been saying our temperatures are supposed to be half a degree above normal, toggling between a third and a half a degree from now the whole way through the winter, the whole way into April, and then starting to fall in July. That looks suspiciously like the beginning of a developing La Nina, especially when you look and see we've been warm for all of 2019, and we were warm into 2018. You know, we're going to have to pay our price at some point. If we don't pay it this winter, we're going to pay for it next winter. Anyway, according to this model, staying neutral, biased warm, not El Nino. You got to be half a degree or better for, what is it, like 5 consecutive months. I don't think we're going to make that here. So just neutral, and I think that is even maybe a little bit on the high side. But basically, an ENSO neutral winter coming up. So no significant support for storm development, but nothing actively suppressing it. Just kind of a normal year, though with the cold water in the East Pacific and the preponderance of high pressure so far, it's a little bit early in the season, and the jet stream being a little bit further north than normal. I think that some of this cool water situation that occurred right here back in summer into the fall has already predisposed the jet stream to be a little bit north of normal. And so we'll say, probably an average winter at best, maybe a little bit below average. But you know what? That's better than La Nina. We'll take it. Precipitation-wise for California, probably not so great. We'll see. It's hard to tell, but on these borderline years, it typically tends to be a little bit below normal. We'll see. So the immediate forecast for right now, wind swell for this week, but it looks like a series of storms, one in the Gulf, one on the dateline, maybe one behind that, are to set up. So certainly some north-angled swell focused on the U.S. West Coast, but some for Hawaii as well, and then wind swell in between. Snow-wise, nothing yet. And if anything, things getting pretty dry by the end of the week, driven by the inactive phase of the MJO. But longer term, as the MJO turns active in the November timeframe, hey, things are going to expected to get a little bit better, stronger storm pattern, maybe precipitation, maybe some snow at that point in time. Then as we get into December, things backing off a little bit again then, but then we'll see what happens beyond that. And again, it's kind of crazy to try to believe a model 3 months out from now, but it gives you at least a guideline of where we're headed towards. So, some surf is expected, something to ride, make the most of it. And if you enjoyed the video, hit the like button. Comments are always welcome. Would try to reply reasonably quick. Also, you can subscribe to the video down there in the corner somewhere down, other side, over here. There we go, down there somewhere. There's a button. You can hit the subscribe button. It will send you an email. Also, click the bell. There's a little bell next to the subscribe option, and then you will get notified every time time we update the video, but we typically do it on Sunday evenings. There's also links. Visit stormsurf.com. Almost all the data you've seen on this presentation comes from there, and you can follow along daily. Of course, there's the wave models, there's buoys, there's all kinds of info there. So take a look, and thanks for watching. We'll do this again next week, same time, same channel.